Welcome to the walkthrough for assignment 1B in my CS253 class. The purpose of this assignment is to deepen your experience using Java's functional programming features and their integration with Java's parallel streams. In particular, in this assignment, you'll develop an app that uses Java parallel streams to obtain, transform, and store images. Like the first part of this assignment, the code you write here has a GUI, runs as an Android client app, and performs all image processing locally on the client device, or on your emulator if you're using that. Please use this GUI along with the unit tests discussed below to help evaluate and debug your solution. The following resources may be helpful in completing this assignment. Detailed overviews of the Java Parallel Streams framework are available in this YouTube playlist. Naturally, we'll cover this material in class, which will also be available in my YouTube CS253 playlist here. In addition, the book Modern Java in Action is a great resource to learn how to program with Java parallel and sequential streams, as well as other topics we'll cover later in this course in the assignments there. Before you complete the initial submission of Assignment 1B, you'll need to do the following. Revise your implementation of Assignment 1A, taking into account my review comments since it forms the basis for the client app in this assignment. Please come to office hours or post questions on Piazza if you have any concerns about your Assignment 1A solution and/or my comments on it. The Image Crawler app is packaged as a project using Android Studio. This app is written in both Kotlin and Java and demonstrates many Android capabilities. For the purposes of Assignment 1B, however, you only need to be aware of the following directories. Image Crawler crawlers, which contains the skeletons you need to fill in, as we'll discuss below, and Image Crawler source test, which is a set of unit tests that exercise the features you're implementing and are used to evaluate whether you've correctly satisfied this assignment's requirements. To compile this code, you'll need to use the provided Android Studio project. You can run this project by clicking the green Run App button in the Android Studio IDE, which should automatically select an Android emulator to run, assuming you have one created. The app's minimum API is 31, so you'll need to select an emulator that uses an API greater than or equal to 31. I recommend API level 32. If you don't already have an Android emulator, you can create one by clicking on the AVD Manager button in the Android Studio IDE. You'll need to modify several files containing the skeleton Java code by completing the to-do, you fill in here tasks to provide a working solution. Please don't change the overall structure of the skeleton. Just fill in the to-do tasks, and whatever you do, don't delete the to-do tags, because it makes reviewing much more difficult. In particular, you need to finish implementing the following to-do tasks for this assignment in the Image Crawler crawlers folder. First, you'll need to modify the parallel streams crawler.java file, where you'll complete the to-do tasks in various methods to obtain, transform, and store images. This class uses Java parallel streams to perform an image crawl starting from a root URI. You'll have to make a couple of minuscule tweaks to your sequential streams crawler.java class that you implemented for assignment 1A in order to use Java parallel streams. Depending on the parameters used to run the tests, images from the HTML pages reachable from the root URI are either downloaded from a remote web server or read from the local file system, and the results are stored in the local file system on your Android device or emulator. You'll also need to complete the to-do portion in the student.kt file in the utils directory to set the type field to include just graduate or undergraduate, depending on which version of the assignment that you'll be implementing. Your solution should use no loops or if-else statements in this assignment, and instead use Java parallel stream aggregate operations and functional programming features. Your solution will be considered correct if it passes all the unit tests, is commented thoroughly, and addresses my review comments. There's skeleton code for this assignment available here in my GitHub repository. Now that you've set up your GitLab account, you can pull the skeleton code into your repository, read it carefully, and complete the to-do markers. Please take a look at the wiki page, and in particular, take a look at the portion that describes, I think it's one of the FAQ entries there, might be FAQ entry number 13 or 14, that talks about how to pull code into your repository from my repository. The unit tests in the Image Crawler source test folder are provided to increase our collective confidence that your implementation is working as expected. Please use the Android Studio GUI to run the unit tests locally on your computer, as described here. As usual, testing only demonstrates the presence of bugs and not their absence, so don't rely solely on the unit test to detect problems in your code. Assignment 1B is designed to deepen your experience developing apps using Java functional programming features and Java parallel streams without the need to create threads or program the Java fork join framework directly. The skeletons and unit tests are extensive, though you don't need to understand them all in order to complete your solution. Please start early and ask questions in class, office hours, and on the Piazza discussion forum. Before we dive into analyzing the skeletons, I want to first show you the proper way to open a project in Android Studio. So what you don't want to do is you don't want to click on the top level folder. You don't want to click on your CS253 Fall 2022 folder, otherwise strange things will happen. Instead, you want to open up that folder and click on the particular project that you're going to be working on. In this case, it would be assignment 1B. And you go ahead and click that. It may prompt you and say, do you trust things that are here? And you probably say yes. And then at that point, it'll go ahead and open the project in the appropriate location. If you don't do this, then you're going to get very strange problems. It won't be able to find the Gradle files, and you may not be able to find the SDK and all this other kind of stuff. So please make sure that you open the right folder in the right way in order to get access to all the content. Now that we've discussed the specifications for assignment 1B, let's take a look at the skeletons. If you go into the source main Java edu Vanderbilt image crawler crawlers folder, you'll see there's a number of files here. Sequential loops crawler is the Java 7 implementation that you can use as a baseline for your other implementations of the crawlers. Sequential streams crawler is an empty skeleton file that you should fill in with revisions you make to assignment 1A based on my review comments and any other frequently made mistakes, insights you get from watching the video. And then the next version that you'll fill in, which is really the meat of assignment 1B, is parallel streams crawler. Please note that you always have to copy the code from the earlier solutions into the current solution because grading and reviewing is cumulative. So let's take a look at the comments and the skeleton for parallel streams crawler. As with sequential streams crawler, this particular implementation performs an image crawl starting from a given root URI. In this case, of course, it uses Java parallel streams instead of Java sequential streams. And as you'll see, there's very few changes needed to convert from sequential streams to parallel streams. And that's really the whole point of this assignment, is to show you how absurdly easy it is to go from a sequential to a parallel version. That's also why you're not getting very much time to do the assignment, because it's going to be pretty quick and easy once you've done assignment 1A correctly. So let's go ahead and take a look at the parallel streams crawler file and look at the methods you have to provide. The first one is perform crawl, which recursively crawls a given page and returns the total number of images that were processed on that page. And you can see you take the page URI as input and the depth, which is the current depth, and we have to check that to make sure we're not exceeding that. So your code here will look pretty much identical to what it did from assignment 1A. You have a Java sequential stream that uses a factor method to make a one-element stream containing just the page URI. Then you'll use an intermediate operation to filter out the page URI if it exceeds the max depth or has been visited already. You'll use another intermediate operation to crawl the crawl page method and return the total number of processed images. And then you'll use a terminal operation to get the total number of processed images from the one-element stream. And in this case, please use the find first followed by or else method chain that we've talked about in class and in the videos. So that's a very simple implementation, almost identical, if not identical, to what was in assignment 1A. Now we're in the crawl page method. This also should look pretty much identical to what's in assignment 1A, modulo any fixes that I asked you to make. Here you're going to create and use a Java sequential stream that will call the stream factor method to make a one-element stream containing just the page URI that's passed in as the parameter. You'll then go ahead and get the HTML page associated with the page URI parameter. You can go take a look at your earlier implementation or sequential loops crawler to see how to do that. You'll have a filter intermediate operation to filter out any missing null HTML pages. Please make sure you use a method reference here as opposed to a Lambda expression. You'll then call the process page method from within another intermediate operation to process any images encountered during the crawl. And then you'll use a terminal operation like you had done before for the perform crawl method up here in order to be able to get the total number of processed images from the one element stream. Next, let's take a look at process page. This is where things start to get a little tiny bit different from what you did with assignment 1A. This particular implementation will use a parallel stream to download and process images on this page using the process image helper method that's defined below. And it'll also, depending on what you're doing and what kind of element you're dealing with, you'll also potentially recursively crawl other hyperlinks that are accessible from this page via perform crawl. And ultimately, you'll sum up all the total images that are processed during the crawl and return that as the result from process page. So you'll start out very much like you did before. You'll go ahead and make a sequential stream containing all the image and page elements on the page. And again, make sure you watch the frequently made mistakes video to see how to do this correctly. It's pretty simple, but you didn't need to know how to do it. Otherwise, the unit test will yell at you. Now here's where things get a little different. You'll convert the sequential stream, which is what this method will return up here in step 1, into a parallel stream. And you should be able to figure out how to do that. We've talked about that in class many times, how to go from a sequential stream to a parallel stream in one fell swoop. The next thing you do, and this is where you can do a couple different clever things, you can then map each of these elements, either a page or an image, into a count of the number of images produced either by processing an image or by crawling a page. And here, please make sure you don't use any if-else statements, but instead you can either use the ternary operator, which is the question mark colon operator in Java, or if you're super duper clever, you can actually do a direct index into a 2-element array. Very few people have ever come up with this on their own. I'll probably show it in class at some point because it's so cool. But either of those approaches works fine. And then you'll finish by summing the results together. And here you really should use the sum terminal operation. Make sure also that when you do map to int as opposed to map, because it's more difficult to sum things if you use map. You have to do another conversion, so use map to int. Now let's come down to process image. This is also pretty much identical to what you did in assignment 1A. You're going to create and use a Java sequential stream that will obtain a one-element stream using a factory method, and that one-element stream will just work with the page URI. Then you'll get or download the image from the given URL. Please make sure you use a method reference here, not a lambda expression. You'll then filter out any missing null pages if something goes wrong. Again, use a method reference, not a lambda expression. Then you go ahead and transform the image and return a count of the number of transforms applied. And here, again, you should be calling helper methods down below, but make sure you do it with a method reference, not a lambda expression. And then the final thing you do here is you'll go ahead and count the number of transformed images, so you have a count of the number of things that you got. Let's take a look at transform image. That is provided for you, so you don't have to do anything. And the last method you have to implement here for assignment 1B is transform image locally, which will do the processing in the client application as opposed to trying to do it on the server. We'll cover the remote server in the next assignment, assignment 2. So for transform image locally, this is also very similar to what you did for assignment 1A, except here you're going to make a parallel stream. So you'll convert the list of transforms into a parallel stream. You'll go ahead and then have a stream where you'll first attempt to create a new cache item for each image, filtering out any image that's already been locally cached. Then you go ahead and use an intermediate operation to apply each transform to the original image to produce a transformed image. Then you go ahead and filter out any null images that weren't transformed. And here, please make sure you use a method reference, not a lambda expression. And then finally, you'll count the number of non-null images that were transformed. So those are the steps that you will be applying here for the skeleton for assignment 1B. And if this looks very similar to assignment 1A, that's exactly the point. We're making it parallel. It'll run a heck of a lot faster, especially if you have a multi-core device or a multi-core machine that's running your emulator, than the sequential version. And if you run it and look at the output, visually you can actually see things downloading and processing and storing in parallel. Now that we've walked through the specification and skeletons for assignment 1B, let's take a look at how to run the unit tests. As you can see, there's a bunch of tests here. There's tests for the parallel streams implementation. There's also earlier tests for the sequential streams implementation. It's essential that you fix any problems with your earlier assignments for later assignments or for the current assignment, because the grading is cumulative and all the tests run. So you should be aspiring to get green check marks for all the tests. So let's go ahead and run the tests. There's a couple different ways to do it. Typically right-clicking on the test folder and then clicking the button. We'll go ahead and compile and run the tests. As you can see here, all the tests ran as expected. They all passed. They all have little green check marks. There's about 30 tests that are being run here. And this is no surprise since this is my implementation that it would pass the tests, because otherwise I'd be doing something amiss if I didn't have a way to implement my own code to pass the tests. But basically, that's what you should strive for as well. You should see that you can get green check marks. And if you're getting non-green check marks for any of these tests, please take a look and try to figure it out. And if you're having trouble, don't hesitate to come to office hours.